So today we're going to talk about more exponent rules. So if you will add that to your table of contents. And our last class we went through and we talked about just individual exponent rules. So today what we're going to do is we're going to look at what happens when we combine all of these exponent rules and how do we simplify even larger exponents. So the first thing that we're going to do, I'm just going to do some examples with you, talk you through it so you can see exactly what that would look like. And if you have any questions, you can send me a note in Google Classroom. So we're going to do about 6 examples, okay? So example 1, x to the 4th to the negative 3rd times 2x to the 4th. And we did talk about last class, so notice that the 2 is the only 2 that we have. This is technically 2 to the 1st power, and we do not have another one of those bases. We also have a power to a power here, so we can multiply this. So I'm going to multiply all of this out. I'm going to write it out so you can see 4 times a negative 3, and then we have times 2 to the 1st, x to the 4th. I'm going to break this into steps, so we'll worry about this over here in a minute. So I have x to the negative 12, because 4 times a negative 3. 2 to the 1st, x to the 4th. So now I just have my 2. I don't have any other like bases that are a 2, so I'm just going to go ahead and write it. But then I have my like bases of x. So I have x to the negative 12, and we're multiplying them, so we know our rule is to add. So I have 2x, a negative 12, and 4 is a negative 8. And you would think you were done here. However, remember, negative exponents go in the denominator. So my final solution to this is a positive 2 to the 1st over x to the 8th. And we put this in the denominator because that was a negative exponent. This stays in the numerator because it was positive. So when we start mixing these rules together, you're going to have to take it one step at a time, kind of like we did when we were doing order of operations in 6th grade. So here's another one. N to the 3rd power. This one is similar, 2n to the negative 1. So if you want to pause me and try this one yourself, because you can see that it is very much like the one we just did, and then unpause me to see how you did. So welcome back. We're going to distribute n to the 3 times 3, 2 n to the negative 1. 3 times 3 is 9. And again, that 2 is technically to the 1st power. We don't have any other 2, so we're just going to write it in the front. When we have like bases, we add our exponents, and we get 9 minus 1 is 2n to the 8th. Now this one is a positive exponent, unlike the one we had over here. So you're simply going to leave it just like this, because since it's positive, it stays in the numerator. So hopefully you did okay on that one. Example 3 is going to be 2y to the 3rd power times 3x y cubed all over 3x squared y to the 4th. So you get a lot going on here. So we have some like bases and some that aren't. So I'm going to take my regular numbers. I'm just going to write them over here. So I have 2 times 3 divided by 3. And I'm just going to leave those alone. And then I am going to put a 1 on my x here. I have like bases of y's and I have like bases of x. So my x's are being divided. So I know that I need to take and I need to subtract them. And my numerator always goes first and my denominator goes second, so this becomes a 1 minus 2. My y's on my top, I have like bases of y's, and when I'm multiplying, I add 3 plus 3, and then I have a division, so I'm going to subtract my 4. And now I can start working these out. So 3 times 2 is 6, divided by 3 is 2. 1 minus 2 is a negative 1. 3 plus 3 is 6, minus 4 is 2. So I can write this as 2. Now notice this is a positive exponent and a positive exponent. This one's a negative. So I know I'm going to have this in the denominator. So in my numerator, 2y squared all over x, or you can write x to the first. It doesn't matter if you have the 1 or not. And now we're done. Here's one similar to that if you want to try it, and you can pause me after you've written it down, and then I'll explain it. X cubed, y cubed times x cubed all over 4x squared. So if you want to try this one and then come back, I can see here that I have like bases of x. So in my numerator, I'm going to add them. And then I have 1 in the denominator, so I'm going to subtract it. I have my y to the third here. I'm going to leave this 4 in my denominator. I can write 4 to the first if I wanted. So I'm going to deal with my x's. 3 plus 3 is 6, minus 2 is 4. It is positive, so it's going to stay in the numerator. Y to the third is positive. It stays in the numerator. This 4 is going to stay in the denominator. So I have x to the fourth, y to the third over 4, or you can write 4 to the first. This one's similar, but a little bit more elaborate. So you're really going to have to learn these rules. So we're going to say 3x squared, y squared, all over 2x to the negative 1. Now remember, there's no parentheses here, so this negative 1 is only on the x times 4y x squared. I'm going to put a 1 on my y there. So again, I'm going to deal with my integers first. So I have 3 over 2 times 4. And then I can deal with my bases. I have like bases of x and I have like bases of y. So I have 2 minus 1 plus 2. And I'm going to put this 1 plus 2 in the parentheses because it is in the denominator. And so I would add these together, which is a positive 1. So hold on. Actually, I wouldn't put this in parentheses. I'm going to write it differently. I'm going to write minus 1, and then because it's still in the denominator, minus 2. And then we can go through, we can look at our y's. 2 minus 2. So I can simplify this to 3 over 8. This is going to be 2. You can see here these actually would cancel, so you're just left with this negative 1. 2 minus 1 is 1, minus 2 is a negative 1. So I know that goes in the denominator. Y to the 0, this is just 1. This technically goes away. So I'm going to write 3/8 and I'm going to put my x down in the denominator. All right, the last example that I have for you is going to be an area problem, because you are going to have one like this on your quizzes. So if I have a rectangle and it has a length of x to the fourth, y to the third, and it has a side length or side width of 2y squared. So I want to find the area. Well, I know that area is length times width. So I need to take x to the fourth, y to the third times 2y squared. So my 2, my integer, my coefficient here, it doesn't have any other bases. I actually don't have any other x's either, so I can just write those, 2x to the fourth. These, though, my y's, those are like bases, y to the 3 plus 2. So this becomes 2x to the fourth, y to the fifth. Okay, so hopefully that helps. Please let me know if you have any questions. Go ahead and work through the quizzes. And you should have enough time. I'm also going to post another notes video on polynomials. So next class, we will discuss the quizzes on more exponent rules, and then we will take a little quiz on exponent rules, and then we'll go into polynomials. Have a great evening.